Hello students. Now let us see the next topic called DES. DES stands for your Data Encryption Standard and it is the most widely used block cipher in the world. It was adopted in the year 1977 by the now standard called as NIST. So it basically encrypts 64-bit data using a 56-bit key, and there are two processes involved. So there is a diffusion that is achieved through numerous permutations, and confusion is achieved through the XOR operation and the S boxes. Now let us see the history of DES. IBM developed Lucifer cipher. It was led by a scientist called Pestel in the year late 60s. So he used a 64-bit data block with a 128-bit key, and after that there were a lot of modifications, and finally IBM submitted the revised Lucifer, which was eventually accepted as the DES standard. So this is the overall block diagram of your DES encryption, where you can see the DES encryption. It consists of 16 rounds, and we have the plain text that is being passed in one side, and the key is passed through the other side, and finally they arrive at a 64-bit ciphertext. So first, let us see the 64-bit plain text is passed through a initial permutation table, and the output is the 64-bit plain text. So this plain text is passed through 16 rounds. Likewise, the 64-bit key is passed initially through a permuted choice table, and the output of the table will be a 56-bit key, which will then be left circular shift will happen, and the output of the left circular shift is then 56 bits, which is then again passed through a permuted choice 2 table, where the output will be of 48 bits, and this will be acting as the key for the round 1. So here you can see K1 is equal to 48 bits. So this 64-bit plain text along with the 48-bit key is now passed to the round 1. So likewise, at the end of the 16 round, there is a 32-bit swap that is happening, and the output of that is a 64 bits, which is again passed through a inverse initial permutation table to produce a 64-bit ciphertext. Now let us see what will happen in each round. So the next diagram will show you the single round working of the DES function. So this 64-bit plain text is actually divided into 32 bits left hand side and 32 bits in the right hand side. So likewise, the 56-bit key is also divided into 28 bits for your left hand side and 28 bits on your right hand side. So this both passes through the left shift, and then it is passed to a permitted choice table, where the output will be of 48 bits, which will be the key for the round 1. So likewise, coming to the plain text, so the left hand side is passed to the right hand side, and the right hand side is passed to the left hand side. So, and also the right hand side 32 bits is then passed through an expansion permutation table, where the output will be 48 bits. So this 48 bits from the right hand side is then XORed with the 48 bits of the key to produce a 48 bits as the output. This 48 bits will be then passed through a substitution box or S box in your DES to produce a 32-bit output. So this 32-bit output will again be passed through a permuted choice permutation box, where you get the output as 32 bits, and the output is then XORed with the left hand side bits to get the 32 bits as the output. So DES S boxes. So S boxes, there are 8 S boxes which map 6 to 4 bits. So each S box is actually 4 little 4-bit boxes, and here you can see the S box diagrammatic representation. So here we can see the right hand side 32 bits is then passed through an expansion table, where you get the 48-bit output. So this is an XORed and passed via the S box to produce the plain text, which is of 32 bits. So this is the S box function. So there are 8 S boxes. So DES decryption. It is same as the encryption, except the application of the key is reversed in your DES. What is an avalanche effect? The key desirable property of encryption algorithm is your avalanche. So whenever there is a change, one bit change in the input, actually it will be affecting half of the output bits. So that is basically called as your avalanche effect. So DES exhibits strong avalanche effect. What is the strength of DES? Key size. Key size is the strength of the DES. We are having a 56-bit keys, and so we have 2 to the power of 56, which is nothing but 7.2 into 10 power 16 values we are getting. And a brute force search looks very hard in this DES. But recent advances have shown that it is possible to attack DES too. So now we have to consider any alternatives to DES. So that's what we have moved to AES. So coming to the alternatives of DES, so we have multiple encryption and DES. So we are having various functions like double DES, triple DES with 2 keys, triple DES with 3 keys. So now let us see one by one. So the potential vulnerability of DES to a brute force attack made a considerable interest in finding an alternative. So the alternative was to use double DES and triple DES. So now let us look at double DES. The simplest form of multiple encryption has 2 stages and 2 keys. So which is nothing but your double DES. So in double DES, how does the encryption or how does the ciphertext is produced? So the ciphertext is produced by encrypting the plain text with key 1 and again encrypting the same content with key 2. So it takes order of 2 to the power of 56 such steps in order to do the attack. So the decryption will be the reverse process. So first you decrypt using K2 and then you decrypt using K1. So now the next method is called as triple test with 2 keys. So triple test with 2 keys is a popular alternative to single test. So the encryption and decryption stages are equivalent, but the chosen structure allows for compatibility with single DES implementations. Hence, we have to use 3 encryptions. So here you can see that we can either use two, dis- 2 keys or you can also go for 3 keys. So now here we are using 2 keys for doing the encryption. So first we can see the plain text is encrypted with the key called K1. It is again decrypted using the key called K2 and the whole is again encrypted using the key called K1. So, but if K1 is equal to K2, then it is equivalent to working of the single disk only. Now, triple disk with triple keys. So, from the term itself, you can understand we are using 3 different keys for doing the encryption and it is considered to be somewhat secure. So here the ciphertext is basically the plain text is encrypted with the key called K1. It is again encrypted with the key called decrypted. It is decrypted with K2 and again it is encrypted using K3. So by doing in this way, we can see that the cipher is more secure and this is used by various applications like PGP and SMIME. So PGP is used for your mail. It is called as your pretty good privacy. And SMIME is your secure multi-purpose internet mail extension protocol that is basically an internet standard. Thank you.